introduce.
My name is Dechen Dem.
Okay, my name is Sunya Nuchapong.
My name is Varit Mesri.
My name is Zwe Nyan Htet.
My name is Utsav.
Hello, my name is Napat Boonyarattanamongkol. I feel hungry today. I think I should go eat something with my friends.
I'm Jay, and today I'm gonna tell you about what motivated us to make this invention, right? So, my friend and I, we were deciding what should we have for dinner. He said KFC, I said McDonald's, because I like McDonald's better than KFC. But my point is, we don't know which restaurant we're eating tonight because we can't decide. We don't have like a spare coin, spare change to toss around, and so my friend just pulled out a laptop and start making a circuit, right? So basically this invention is a rock, paper, scissors machine that would decide which restaurant we're gonna eat tonight. So how this works is basically we have player 1 and player 2, right? So with just one click of a button, we can decide what restaurant we're gonna eat. So let's me demonstrate, right? Let's say this is my friend and this is me, right? Okay, my friend 1, we're gonna eat KFC, right? So zoom into this value here. We gotta change this value here so it's when it's compared with the comparators, it ain't gonna be the same number because with this and this we all be the same number, it's gonna get the same result, right? So let me try again real quick. Let's say this one I gonna buy a new phone, and this one I'm not going to buy a new phone, right? So 3, 2, 1, and boom, I buy a new phone. Okay, so this is basically what this circuit do, which is it's randomly design a number and compare it with a comparator and yield the result, right? It's like paper, scissors, and rock, right? So that's like 3 results that could come out of this. Okay.
I'm going to explain how many components we used in our Logisim. So in total we used 7 components. The first component is called as clock. This one is called as controlled buffer, and this one is known as pin, and this one is random generator. Random generator is connected to 3 comparators, and each comparator is connected to pin, and then they are also connected to several logic or gate, and then they are connected to several LEDs to show the output of the hands, and this represents the hands. It's paper, rock, and scissor, and we made this 2 copies so that we know each players.
Me, Utsav, and Sanya are going to explain how each of the parts work and their purpose.
Okay, the purpose of the clock is generate a continuous periodic digital signal that oscillate between high is 1 and low is 0. Okay. Another component is pin. Pin is a pin served as an input or output point for signal and in the circuit. And another component is random generator. The purpose of it is produces the random digital signals. Okay.
Next is the comparator. The purpose of the comparator is to compare two binary values and generate a specific output based on their relationship. So how it works is it can compare binary numbers to determine if one is greater than, less than, or equal to the other. So of course common outputs are A equals to A is greater than B, and A is lesser than B. So the topmost is if A is greater than B, then this lane gets enabled. The middle one is if A and B are equal, and the last one is if B is greater than A. Last is it's useful for decision-making circuits such as those in sorting algorithms or control systems like we've made over here. Next one is the LED that we've used. It's a light emitting diode, and its purpose is to display the digital state of a signal visually. How it works: while on, it's lit, so when the input signal is high, which is binary value of 1, it is lit, and off is when its binary value is 0. LEDs are used for debugging and visualization, like we've used over here to show rock, papers, and scissors, and to quickly observe the state of a signal or a circuit's output. So therefore, lastly, these like components have helped us to generate and control signals, also provide or observe input and outputs, also evaluate logical or numerical relationships. And yes, all of these tools were essential in our designing and implementation of our project circuit.
My name is Zwe Nyan Htet, and I'm going to explain the components of the wiring. Now, there are 3 components. One OR gate. That one OR gate is for scissors, as I see in the diagram above, while this OR gate represents a rock. While there's no OR gate on the third wiring, this represents paper. Meaning 5 fingers is paper. We will explain the scissor in detail. When you look at the comparator in scissor part, the wiring connects to the first OR gate and the second OR gate. On the first OR gate, that first OR gate connects to the index finger and the middle finger of it. As you see the second OR gate, that second OR gate connects to the palm of the hand. So when you light both of them, you get palm and both fingers representing a scissor. Now you look at the rock. When you look at the rock, the wiring of this OR gate is activated, which means that these two were cut off. No middle finger, no index finger. The only remaining thing was a palm, which means that this represents a rock. Now when you look at the third comparator, the last one, we realize that this middle finger and the index fingers will light up. So it's a palm. However, if you look at the wiring again, the 3 more fingers were included. They include the thumb, the pinky finger, and the engagement finger. So altogether, 5 fingers and a palm were formed, which is actually a paper, forming a paper. So this is how it works, the wiring of this machine.